So I just want to show you with this video how to read off a micrometer scale. And this is used when we're measuring the diameter of a wire in the experiment of measuring the resistivity of a wire. So what you have, if you look over here, is you have a set of jaws that open, and then you can put the wire in between those jaws, tighten it, and that once it is tightened around the wire, it will give you a reading of how thick that wire is, and it gives it to you very, very accurately to 2 decimal places, and in fact you can even eke out 3 decimal places on it. So first thing I'm going to do is I'm going to close the jaws. So if you look on the very left of your screen there, you'll be able to see the jaws closing, and you hear that clicking? That is a clutch. So it's this thing here at the end that it allows the same amount of pressure to be put on the jaws each time. Now you can notice that this closes exactly, almost exactly at the 0. So the 0, if I use my key as a pointer here, my 0 mark here lines up with the 0 line, basically the line that I read the scale off of over here. Okay, so that line that comes out, that's what I'm looking to see where that lines up with these little notches along here. So nothing in the jaws, you want those two to line up there. We'll talk at the end if they don't line up, what do you do? So you can see that the numbers represent 0.01. Now that's written just over here, 0.01 of a millimeter. So you can think of this as hundredths of a millimeter. So 100ths, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not going to count all the way up to 100, but there's 20 hundredths, 30 hundredths, 40 hundredths, and then something funny happens. It goes back to 0 again. Now what they're doing here is they have, to make this easier to read, only put 50 hundredths going all the way around the drum. Okay, so if we go back to 40 here, 41, 2, 3, 4, 45, 46, 47, 48, 49, and that would be 50. Now, at this point, you might say, well, how do I know that that is not just 0 millimeters? So if I use my lovely pointy key here again, look at this little dot dash that has appeared down at the bottom here. That dash at the bottom is telling me half a millimeter has basically been measured. And anything that I'm measuring above here, and you can see that that dash becomes more and more visible as I rotate here. So for instance, if I take this reading, this looks like 20 hundredths of a millimeter. But because I can see this bottom little dash here, I have to add on half a millimeter onto that. So half a millimeter is 50 hundredths. So I have 50 hundredths plus 20 hundredths, that's 70 hundredths, or 0.7 of a millimeter. So that would be 0.8 of a millimeter, and that would be 0.9 of a millimeter, and look what is starting to appear at the very top up here. My trusty pointy key, see this little dash that is just starting to peek out? That's the 1 millimeter mark. Okay, so remember 90 hundredths, 0.9 of a millimeter, 0.95, and then back to 0. Now I have that slightly tilted, so this would be the way that you would actually see it. So now that's reading 0 on the circular scale, but because you're able to see one dash at the top here, that means it is reading 1 millimeter. So the bottoms, this is half a millimeter, the top is 1 millimeter. So let's open this out here and see about taking this reading. Okay, so what is that reading right there? And this is my trusty lock. Okay, so let's lock it there and say, okay, what is that reading? So the first thing you do is, so this again would be the way that you would look at it, is you look at the top and we can see there is 1 millimeter, 2 millimeters. Now I'm not able to see the third dash, so it's 2 and a bit millimeters. But if we come down to the bottom, we're able to see there is the half millimeter mark visible. So I'm reading this as 1, 2, 2.5 millimeters, and then I'm coming along here to add on whatever is on this reading. So the 10 hundredths is down here, the 20 hundredths is up here, so this is 10 plus 11, 12, 13, 14, 15 hundredths. Okay, so 2.5 millimeters plus 15 hundredths are 0.15. So 2.5 because 1, 2.5 on the bottom, and then the 0.15 from this scale over here, and that gives me 2.65 millimeters. So that's incredibly accurate, 2.65 millimeters. And realistically, if I release this here, you could in fact go to a third decimal place if you got something like that there. So if you look at that where it's halfway between, in that case, 15, what's that, 16.5. Okay, so that's the 15 mark, 16 and 16.5. So you could in theory go to an extra decimal point on that. Okay, let's do one more. Round and round we go, and let's say we'll mark it here. Okay, so what's that reading? So again, look at the top, 1, 2, 3 millimeters. There is no half millimeter visible on the bottom, so it's just 3 and whatever this scale is reading here, and that's just before 30, 29, 28. So that's 3 millimeters and 28 hundredths, or 0.28 of a millimeter, 3.28 millimeters. Okay, so just look at that and make sure you are happy that that is 3.28 millimeters. So one last one, let's do this. Okay, let's make that a tricky one. Now, what have we got in the top? We've got 1, we've got 2, we've got 3 millimeters. We have just about able to see the 0.5, but when you look here, you are almost at the 0 mark. So remember that 0 mark can mean 0 or it can mean 0.5. So this is 0.49. Now, what you have to ask yourself here, does it make sense that this is 3.49, or is it 3.5 plus 0.49? Is this 3.99? Because it has to be either 3.49 or 3.99. Because you're able to see that bottom half millimeter here. Well, because you can just about see that. If you are before the 0, it's going to be 3.49. Let's say I went above it here, that would be 3.51, 3.52, 3.53, 3.54, 3.55, okay? 3.6, 3.65, 3.7, 3.75, okay? And if I go all the way up to 3.95, you can see that, yes, I can definitely see the bottom part down here, but I'm actually just able to see the top 4 millimeter mark, which I should be able to. 3.99 is literally right beside 3.4. So you use your own judgment there for ones that are very close to the half or the full millimeter mark. Okay, that is it. I hope that clears it up.